Today on How It's Made. Horseshoes, trotting out the equine footwear. Dishwashers, we visit a factory with a spotless record. Graphite fly rods, this story is sure to lure. And frozen pizzas, defrosting the secrets of how they're made. But first, horses first wore leather and metal shoes around 500 AD to protect their hooves from wear and tear. A farrier is someone who makes horseshoes and applies them carefully. Today they're usually made of steel, aluminium or plastic. So let's trot on and see how they're made. A horse's hoof has a hard outer wall like a fingernail, only much thicker. The farrier attaches the horseshoe to this wall with heat and lead nails. The horse feels no pain because the nails don't reach the sensitive tissue inside. Horses get new shoes about every 5 weeks. After removing the old ones, the farrier uses a file to trim the wool's growth since the last change, about 10 millimeters. He measures the hoof's contour, marks the measurement on a steel bar, and cuts it to size with a rotary saw. Steel is the material of choice because it's affordable and durable. Next, he heats the bar until the middle's white hot. He brushes off any dirt, then dips the bar in water to cool it. Then he hammers the ends to redistribute the metal towards the middle. This widens and thickens the part of the horseshoe that gets the most wear, since the front of the hoof hits the ground first and hardest. After reheating the bar, he hammers it again, this time with no cool down. For larger shoes, 2 farriers take turns hammering, so that they can shape the steel while it's still hot and pliable. Using a drafting compass, the farrier gauges where 2 grooves for nails will go. He reheats the bar, then holds a sharp-ended tool against it while another farrier drives it in with a hammer. The nails won't protrude when they're embedded in the grooves. These areas will also fill with dirt to give the horse traction. The farriers round the sharp edges of the horseshoe so the animal won't cut itself when it's lying down. They make the nail holes by first driving this tool into the grooves. Then they use another tool to perforate the steel, hammering it into the shoe over an opening in the anvil that lets the tool pierce through. The farrier then repeats these steps on the other side. It takes 2 farriers about 15 minutes to make a pair of horseshoes. The first farrier heats one shoe, while the second hammers the other. Like the hooves, the front and back shoes are differently shaped. The front pair are rounder, the back ones are more oval, because the horse's hind hooves have evolved to dig into the ground for traction. The farriers also hammer part of both curves, flattening the edges into raised sides called clips. These help the shoe fit onto the hoof. For larger workhorses like Clydesdales, the farriers bend the ends downward to give the feet more traction. It's not uncommon for a 900-kilogram horse to have to pull twice its weight. Now time for the fitting. After heating the shoe, but not as much this time, the farrier uses it to melt the outer part of the wall. This makes an imprint that later helps him place it properly on the hoof. Horses first wear shoes at about 3 years old, the age when they start working or competing. The farrier fine-tunes the fitting with a metal filing tool, curving the edges further to make them even safer for the horse. Next, he shines the steel with a metal brush. Depending on the foot size, the finished shoe can measure anywhere from 7 to 25 centimeters across. Now to attach the shoe. The farrier first files the hoof to remove any dust or sharp edges. He slips on the shoe, then gently hammers as many as 3 nails into each side. The nails are about 5 centimeters long. They're made of lead, a metal that's easy to bend. And that's what he'll do after hammering them through the wall. He clips off the ends and bends the rest in towards the wall. Then he uses other tools to gouge small crevices in which to bury the ends. This makes it easy to straighten out the nails and yank off the shoe when it's time. He also hammers the hoof against a template to stabilize the shoe. Next, he files the hoof, and finally, the horse is ready to stroll. When it comes to horse footwear, it's all about function, not fashion. So whether you've got a pony or a stallion, make sure the shoe fits. In 1886, an American, Josephine Cochran, built a motorized wheel with wire compartments for dishes, turning inside a copper tank filled with soapy boiling water. But it wasn't until the 1950s that domestic dishwashers came on the market. And arguments about who did the dishes were gone forever. Building a dishwasher starts with a watertight container called a tub. Some high-end models have stainless steel tubs. The rest have tubs made of molded plastic, usually polypropylene. Workers screw 2 pairs of plastic wheels to each side of the tub. They'll support the sliders on which the upper dish rack moves. The lower dish rack rolls along the bottom of the tub. This steel frame helps strengthen the tub. They fix a steel plate at the bottom to shield the plastic from the heat of the motor. Then they attach steel legs to the frame. They install a rubber reservoir called the sump. It collects the water that flows to the bottom of the tub. They screw in a 2-part ring to hold the sump in place. The heating element is a ceramic insulated iron cable. This filter traps food particles washing off the dishes. After fitting an O-ring seal to make the sump leak-proof, they secure the heating element by screwing ceramic insulators to the protruding connectors. Now for the polypropylene wash arms. This model has one at the bottom, with a tower that juts out for a larger spray span, and a second wash arm at the top. The motor pumps clean water directly to the bottom wash arm, and through this flexible hose to the top wash arm. Once they connect the hose, they spin the wash arm to make sure there's no obstruction. Meanwhile, workers connect key components to the dishwasher's circuit board. This metal box is the timer. It controls the wash and dry cycles. It activates this green lever to trigger the white lever to open the detergent dispenser at the right moment in the wash cycle. The detergent dispenser is located on a plastic panel that will line the dishwasher's door. They call this panel the inner door. The seal will prevent water from leaking out, and it also provides some soundproofing. A press runs over the inner door, driving the seal evenly all around. Now they screw the inner door to the outer door. The assembled door hooks onto hinges at the base of the tub. This machine presses the hook and hinge together so that the door doesn't come unhinged. The dishwasher's motor is relatively quiet because it uses an inherently low-noise induction drive design. The white machine attached to the motor grinds up food particles so that they don't clog up the drain. The last technical step is to connect the various wires. Before applying the finishing touches, workers conduct a seal test. They flush each tub with water to check for leaks. In this portable dishwasher, workers install cement blocks as a counterweight so that the washer won't tip forward when you open the door. And because a portable usually sits in full view, it also needs sides and a top. This top is decorative laminate on medium density fiberboard. They screw it to what's called the wrapper, a three-sided panel made of painted steel that covers the sides and back. A clean look to go with your clean dishes. Now who's going to empty it? Not me. Coming up on How It's Made. Graphite fly rods. We cast our eye over this one. And Mamma Mia frozen pizzas. Yum yum. See you after the break. Welcome back to How It's Made. Graphite is a space-age material, lightweight, flexible and strong. The very qualities that make it useful in space also come in handy at the river or lake. It explains why graphite fly rods are now mainstream in the fishing world. To make one, they start with a sheet of graphite. They cut out shapes following precise measurements. One mistake here and the performance of the rod will be compromised. This will be a three-piece rod with a butt piece, midsection and tip. They place a shape on a tapered steel mandrel and peel away the paper backing. This machine rolls the graphite shape around the mandrel. They make all three sections of the fishing rod the same way. A graphite strip at the end is used for reinforcement. The graphite remains on the mandrel for the next step. They wind polypropylene tape around the graphite to squeeze out any air pockets between the layers. Then it's into the oven to cook at 125 degrees Celsius for about an hour and a half. The tape won't melt, but resins in the graphite will, baking the rolled layers together. Afterwards, they remove the shrink tape and pull the graphite blank off the steel mandrel. Then the rod blanks go for a dip in a special finish, which turns it a deep blue. They bake on the finish for an hour and a half, again at 125 degrees Celsius. Afterwards, they measure the rod sections, cut them to size, and fit them together. Bending without snapping is the graphite rod's strong point. They hot glue the stainless steel tip to the end. Then they piece together the retainer for the reel. This lock nut will allow the reel to be tightened. The butt plug will keep everything from sliding off. They glue cork rings together to make a handle. Then they shape it with a chisel and sandpaper. The line guides go on next. To secure it to the rod, thread is wound around it. final step ensures the handiwork doesn't unravel. They place the rod in a rotating jig and brush 3 coats of glossy epoxy onto the thread wrap. This not only protects it, but gives it a nice finish. Now, they slide a metal foot into a groove on the reel retainer, and it's ready for the reel to be attached. But before you can cast your line, there is some information that needs to go on the rod, like the brand name and the serial number. A final inspection, and it's almost time to test the waters. The reel snaps into place, and it's easily adjusted with the lock nut. So now all that's left is to cast your bait, sit back and wait, and leave the rest to fate. Millions of pizzas travel daily from the frozen food section of the supermarket to the family dinner table. Thick or thin crust, meat or vegetarian, their convenience makes them a staple in the freezer. But how do they end up tasting so fresh when they start out so frozen? Making frozen pizzas requires a maze of machines. To make the dough for the crust, they combine flour, salt, sugar and yeast with water and oil in a large mixer. They also add cornmeal for flavour. The mixer turns the ingredients for about 4 minutes, kneading the dough. The dough rises for about half an hour. Then they feed it into a chunking machine, which divides the dough into smaller pieces. The chunks travel to a sheeting machine that rolls them into a flat sheet 2.5 centimeters thick. A light dusting of flour keeps the dough from sticking to the machinery. A series of rollers, called quick reducers, gives the dough an even consistency. A flour brush massages the dough, ensuring a smooth surface. Next, stainless steel spikes pierce through the dough with holes 7 to 10 millimeters deep. These holes will stop air pockets from forming in the dough. A large plastic roller with several round forms cuts the circular shape of the pizza crust. The machine automatically separates the leftover dough. The factory remixes it with fresh dough for the next batch. A conveyor takes the dough circles to their next destination, the oven. They bake for 2 minutes between 200 and 315 degrees Celsius. 6 chambers inside the oven automatically control the temperature pattern to ensure that each one bakes evenly. Next stop, the tomato sauce. A tank pumps a steady supply of sauce into a reservoir, drenching a roller, turning inside. A plastic board then scrapes the sauce onto the crusts passing below. The excess sauce drips down, replenishing the reservoir. Mounds of pre-shredded mozzarella are ready to be added. A cheese applicator machine controls the output, so that the mozzarella forms an even layer. Large hoppers load heaps of pepperoni, sausage and other meat toppings into a meat applicator. With the tomato sauce and cheese, the meat toppings cascade down onto the pizza crusts. The pizza is now ready for inspection. Workers take samples off the line and weigh the crust, sauce, cheese and meat to ensure the equipment dispense the right amount of each. Next, the pizzas enter a spiral freezer called a blast cell, where they spend about 20 minutes at minus 31.6 degrees Celsius. An overwrapping machine applies a clear layer of plastic around each pizza, automatically cutting the wrap to fit. A vision control system takes a picture of every pizza, verifying the size, diameter, and checking for any imperfections. The machine automatically rejects any less than perfect pizzas by air blasting them into a separate tub. Finally, an arm pushes each pizza into a waiting box. All that's left now is to heat it up and dig in. Bon appetito. So, whether you're a horse with happy hooves, a contented cook with dishes to wash, or an avid angler looking to catch the best equipment, now you know how it's made.